All right, good afternoon, everyone. Welcome to the Compliance and Security in the Cloud talk. This is part of the Google Apps track. These are some hashtags you can use to tweet about this talk. The picture I took earlier of you all, I posted it with those hashtags. Also, we're collecting feedback for these sessions, so this is the feedback link you can use. Feel free to submit feedback anytime. All right, so let me tell you about myself. My name is Michael Manoochehri. I'm on the developer relations team supporting the Google Apps APIs. That's my handle. Luckily, my name is unique enough, or if you want to get a hold of me, you can just Google me. And as you can tell, my Android avatar is a lot cooler than me, wearing sunglasses, and is a lot better dressed. Now that I've introduced myself, let me find out who you are. This session will have a lot of great information for any users of Google Apps. But if you're in this session, I suspect you're one of these folks. You probably are Google Apps domain administrators or prospective administrators. Possibly you're enterprise information managers. I think there's some CTOs, some chief privacy officers at this conference, maybe some CIOs. You might be system administrators from government and educational institutions, large institutions with thousands of users. And I know some of you are Google Apps resellers, you're independent software vendors, there's system integrators here. If you're one of these folks, this talk is definitely for you. Let me talk about what we're going to cover today. So the first thing we're going to do is talk about what makes compliance and security issues so challenging. We're going to do a brief review about what Google Apps provides out of the box to handle some of these issues. Then I'm going to introduce you to the Google Apps Administrative APIs. And I'm going to talk to you about them in a way that helps you address some of these compliance and security challenges. Then we're going to dive in and look at some code. We're going to take a look at 3 real-life use cases involving policy, security, or compliance challenges. And we'll see how these customers use the Google Apps Administrative APIs to help address some of these challenges. So this is a 201 level session. We assume some technical background. But I'm going to cover, unlike some of the other sessions you've seen at Google I/O, I'm going to cover a very broad range of technologies. So while the code samples I demonstrate are going to be quite simple, I'm going to assume that you know how to do your own development environments, or you're already familiar with some of the technical issues. You've heard of some of the things I'm going to talk about. And as a reminder, this session is, the APIs used in this session are only for Google Apps for business, education, government, nonprofit users, not the consumer Gmail accounts. So let's start. Let's remind ourselves what Google Apps provides for us. What brings value to us from Google Apps? So first of all, collaboration, productivity. We're 100% web-centric, right? So this allows for a lot of great opportunities for collaboration, and that's a great value add for you. Also, innovation. We're always rolling out new features, and you don't have to worry about software upgrades. There's automatic upgrades. Platform independence, a very big deal, right? You're able to access Google Apps from your workstations at home. Your employees can on the road, travel, independent workstations. You're able to access Google Apps from there. But what's most important for this talk is less complexity. Now, if you were at the keynote this morning, you heard Sundar talk about administrative costs and how that's a great deal of the cost for IT infrastructure. And so what Google Apps provides is reduced IT complexity. We want to be the less complex, less to worry about solution, right? So we have less hardware, less licensing costs, less need to provide software upgrades to disparate machines across your network. Okay, so you know all that. That's why you're here. Let's talk about some security things out of the box. Like, what about security? Well, Google Apps provides the same security and the same uptime and infrastructure used for our own Google products. This is great availability and great security. We also lower the barrier of entry to enterprise security features, right? So we have 2-factor authentication, features like SAML-based single sign-on, which I'll cover in a minute. And that's great. But just because we can help you simplify your IT infrastructure, and despite the benefits of Google Apps, just becoming a customer of Google Apps doesn't solve all of your information challenges. And let me give you an example. Can somebody in the audience tell me who these 2 folks are, and don't cheat by using Google goggles? Anyone? No? Anyone from a publicly traded US company? Okay, no guesses. This is Paul Sarbanes and Michael Oxley, right? Some people do know who these are. So, okay, besides being dashing gentlemen and former congressional representatives from the US, these are sponsors of the Sarbanes-Oxley Act, or SOX as we call it. So what did that do? So that was US legislation passed in 2002, in part as a reaction to the fiscal accounting scandals from Enron and WorldCom. It increased regulations on fiscal oversight of public traded US companies, right? Let's see what actually happened. So SOX gave the US government agencies additional powers to ensure that proper fiscal compliance and organizational controls are being followed. So stricter rules around auditor independence. The audits of organizational controls was very important. And I know not all of you are from the United States, and not all of you work at publicly traded US companies, but the point I'm trying to make here is this law passed in 2002 and changed everything for the people affected by it. Regulations can change quickly. Compliance regulations can change quickly, and standards come along all the time. Also, regulations differ from country to country. And what I'm trying to say here is that you never know when these changes will occur. You just have to be ready for them. So in the digital age, fiscal compliance includes information compliance, right? There's many questions around some of these issues. For example, if you're an IT administrator, you want to know, well, what do my internal reporting and control systems even look like? How do I establish a baseline for standard certification? How much does it cost to audit my data? So what are some risks associated with user data? You might have employee leaks. You might have security breaches. How do you deal with these things? So these things are challenging enough in a legacy setting. But when you move to the cloud, what tools do we have to address some of these challenges? And that's really what this talk is going to be about. Now, apart from compliance, there's day-to-day security issues, right? Are my users' passwords safe? Like, how do I know if an account has been compromised? What about my identity management policy? Do I already have one? How do I plug Google Apps into that? And you're going to find out today. So here's the two takeaways I want to leave you with at the end of this talk. And one is, as I said before, dealing with compliance and security issues often means being prepared for the unexpected. And the second thing I want to tell you is the Google Apps Administrative APIs are a set of tools to help you address these custom challenges. Okay, so let me introduce you to the APIs that I'm going to be talking about today. Consider the typical actors in your business environment, right? You have administrators, some of you are administrators. You've all got users, employees, people who interact with data services, right? So these are like documents, Gmail, calendar. And then you have institutions, and those institutions can be your own company. They can be regulatory agencies. They can be some kind of school policy. They can be legal entities, and you need to deal with them as well. You can't leave them out of the equation. So what the Google Apps Administrative APIs do is tie together these actors programmatically and let you create new tools and services to interact with these actors. For example, I'm going to introduce you to the Provisioning API and the Email Migration API. These are used to create and retrieve information about users, and the Email Migration API is obviously for deployment purposes. For user settings, we offer the Admin Settings API and the Email Settings API, and I'll get into those a little later. And finally, for interacting with some of these institutional actors, we offer a Reporting API and an Audit API, and both of these are used for reporting and compliance purposes. Okay, so why Google Apps Administrative APIs at all? We already have a control panel. That's one of the other great value adds for Google Apps. You can manage user accounts, you can create organization units, you can provide different access levels of the services we offer, and we've recently added some finer-grained administrative controls to this panel, right? Well, the answer is obvious. We want to give you the ability to create tools and services to automate complex tasks, less yak shaving, as we call it. We want to allow Google Apps to adapt to custom situations. All of your different needs are, you have different needs. You have custom needs, and we want to make sure that Google Apps can adapt to those custom needs. It's also a great platform to build new software and services. We have the Google Apps Marketplace. You can also build independent software for people. And finally, it's for growing a business, providing services, deployment services, integration services. There's great opportunities here. All right. So in general, the Google Apps Administrative APIs that I'm going to talk about are only available for use by domain administrators. And as I said before, they're available for Google Apps for business, education, government, and ISP users, and nonprofit users as well. And let me say a few words about authorization. Authorization, we suggest using OAuth. I'm going to leave some of the authorization steps out of the code samples I use because there's multiple ways to authorize these APIs. However, yes, we would suggest using OAuth. Why? If you've never heard of OAuth, OAuth is a way to authorize network services without sharing passwords. This is particularly important for these APIs because all of these APIs require administrator access, and you want to share those passwords as little as possible. So OAuth requires a whole separate session, and some of you have probably been to the OpenID and OAuth session that happened, I think, just before this session. If you haven't, you definitely should check out the video recording of it later. It was given by Ryan Boyd. And I'm going to say another thing about OAuth 2. Hopefully you've heard a lot about the OAuth 2 flow. That's great. We're still working on getting that flow integrated into these APIs, but we're working on it, and we'll get that out soon. For now, the Google Apps Administrative APIs work with the OAuth 1.0 flow, And we've just published an article about using the provisioning API with that flow. So for more information, I'll give you some links at the end of the talk. The Apps APIs also use the Google Data Protocol. This is an XML-based standard derived from AtomPub. If you've ever seen an Atom newsfeed, you kind of know what it looks like. These are generally RESTful APIs, create, update, delete resources. Just as an example, this is the shortest Google Data Protocol document I could find. Don't worry about this. Normally, you would interact with the Google Administrative APIs via libraries and service classes. And we have open source Google Data Protocol libraries available for Java, .NET, Python, PHP. There's a few other languages out there that we support too, or that are supported, but not by anything on Google Code. And for the code that I'm going to demonstrate today, we're going to use the Google Data Python client library. All right, so now I've introduced you to the Google Apps admin APIs in general. Let's dig down and see how they're used in practice. I'm going to share 3 stories with you involving actual customer situations with unexpected compliance and security challenges. And we're going to see how the Google Apps administrative APIs were used to address these challenges. Let me tell you the tale of the Google Apps reseller. So I'm going to introduce you to my friend, Subhardeep. I've been working with him for a while. Subhardeep is a Google Apps reseller, works out of Bangalore. He's also a system integrator. He makes his business helping people deploy Google Apps, and he resells Google Apps. He uses the administrative APIs to automate repetitive administrative processes. He builds tools for deployment. He builds alternate administrative consoles for his employees, or for his customers. And he uses these tools to help with billing, so he knows how many user accounts are being deployed on his customer domains, et cetera. So he has many customers who want to migrate their legacy accounts to Google Apps accounts. And you know better than I do as system administrators or CIOs, if you manage user accounts, you don't save passwords in plain text. And even a casual observer of recent tech news knows that it's a bad idea to store user passwords in plain text. Better to store cryptographic hashes of the passwords in case your user database is compromised, right? So in this case, Subhardeep often has customers with account information that's in this format, right? He has maybe a username, maybe a first and last name, and then he's given a cryptographic hash of a password. He's asked to move these user accounts to Google Apps with the hashed password intact. This is a very common deployment issue, right? So how does he do this? He needs to migrate these accounts while preserving this hash password. He doesn't want to ask the customers, the users, for their passwords again. He wants to make the deployment as seamless as possible. How does he do this quickly and securely without violating that customer's identity management policy? Well, luckily, he can use the Google Apps Provisioning API. This is the bread and butter API of Google Apps. This API lets you create and manage users, groups, organization units, nicknames. Read and write access is available for the Google Apps for Business accounts, Gov, ISP versions. But this is one API that's available for all product versions for marketplace applications. And use of this API must be enabled in the Google Apps control panel. It's a very powerful API. Let me give you an example of creating a user account using this API. Before we look at some code, I'm going to show you what's happening behind the scenes with the Google Data Protocol. To create a new user, you would make a post request along with some data in a Google Data document to the following URI. Oh, you would replace, of course, your domain with the domain in question. And what do we send in that post request? Well, here's a Google Data document that shows the user creation data. Let me highlight the interesting parts. Don't worry about the details. So what we're doing is we're going to create a new user named Susan Jones. We're going to provide a cryptographically hashed password. We're going to tell the API which algorithm we've used to hash this password. And we're going to give a first and last name as well. OK. So you wouldn't normally do this unless you're writing your own client libraries or you're running some kind of shell script from the command line. What you'd rather do is use the available client libraries. So let's illustrate what this looks like using the Google Data Python client library. So the class used to make calls to the provisioning API in the Google Data Python client library is called the App Service. We're going to import this service class. We're going to instantiate a new object. I'm going to skip the authorization step. Once we have this service class initiated, we're going to call the create user method. And let me highlight the same data fields that I showed you in the Google Data document. OK, so we're creating a new user named Susan Jones, first and last name, cryptographically hashed password with the MD5 algorithm. The provisioning API supports both SHA-1 and MD5 hash passwords. So great, that was pretty simple. But normally it's not that simple. Normally you don't just create one user account, you create, 10,000 at a time, a lot. Oftentimes you might have a CSV file of usernames, a database, something. So in this case, here's a list of tuples representing multiple user accounts. We have the same thing, Susan Jones, someone named Larry Joe, and thousands of others. So how would we approach this? Well, it's pretty simple, obviously. You'd run a for loop, iterate through the list of accounts, and run the same create user method on every single account. Simple, right? Well, no, it's not that simple. Here's the first tip I'll provide for the provisioning API, and I'm going to highlight this tip because it's useful for the rest of the APIs I'm talking about. Like many of the APIs at Google, we enforce rate limits, but the rate limits for these APIs tend to change with capacity on our end. So the problem with these, the problem that Superdeep is going to face is the administrative APIs tend to be used very heavily in short bursts, right? You're going to make 10,000 calls to the API as fast as you can, or you're going to change every user setting on a huge domain. If you make quite a few calls in a short time, you may come up against those rate limits, and when you do, you'll get a service unavailable 503 HTTP status message. So how do we deal with this? Well, we recommend using some kind of backoff approach, maybe an exponential backoff or linear backoff. Let me demonstrate what that looks like. I'll give you a very simple example of how to deal with this. All right, so Superdeep needs to import some additional modules to make this work. Let's say he imports some time modules to help with some delay, and he's going to import a class called the apps for your domain exception from the Google Data Python library to handle exceptions. Let's set two variables. Let's set a delay variable. This will be the amount of time we wait before making a call to the API. And let's set an increment value. So this is how much time we're going to increment the delay if we hit that rate limit. Let me show you what this looks like. Let's go back to our for loop. So here's our for loop before, the one that we think might cause some problems because we're going to come up against a rate limit if we're provisioning too quickly. We're going to add some additional code. Let's add a while loop. So if the user account is created successfully, no problem. We leave the while loop, move on to the next user. Everything's great. If there's an exception, we're going to handle it. We're going to catch that exception, and we're going to figure out what the cause of it was. If the cause was a 503 status, maybe because we hit a rate limit, or there might have been some network problems between the client and Google, we're going to increment the delay value. It's set to 0. We're going to increment it to 5. We're going to wait that long, and then we'll retry it. So if it works, great. If not, we repeat with a longer delay. And everything will be fine. This is a simple. This is a simple example, but I wanted to highlight this because this is a very common question. We get a lot of administrators asking how to do things as quickly as possible. And in any case, you should always use exception handling when you're doing functions like this. Let me give you a few more tips before we leave the provisioning API. Newly provisioned users take some time to appear in the control panel. A lot is happening behind the scenes when you create a user. Here's another thing you should know. Deleted user data, even if you delete a user through the control panel, you probably may have heard of this already, or through the API, is held for 5 days for security purposes. This is another security feature of Google Apps. If a user account is maliciously deleted or accidentally deleted, 5 days usually gives us enough time to recover that account. And one of the things we're working with the provisioning API is to improve throughput so you don't have to worry about these rate limiting steps at all. So great, so Superdeep's very happy. He was able to migrate these user accounts by keeping these cryptographically hashed passwords intact. What about the email? So Google provides lots of tools for email migration. We have IMAP migration tools, we have migration tools for different legacy email systems, but sometimes those tools can't be used for various reasons. So someone like Superdeep has experienced many examples where he was not able to use the email migration tools. Maybe the IMAP server was down, there was maybe a firewall issue. Sometimes the legacy email is in just some format that he can't parse with the normal migration tools. For cases like this, Google provides something called the Email Migration API. So the Email Migration API lets you move your legacy email to the cloud. It doesn't just let you move mail, it lets you add labels, you can add properties like the archive status of the message. Is the message read or not? Is it starred? This is one API where non-admins can actually use it themselves if the admin gives that permission in the control panel. And finally, this API can only use UTF-8 encoded messages. I've seen cases where people try to use this API with alternative character encodings, for example, Big 5 for Chinese or CJK encoding. To use this API, it's best to encode or transfer that character encoding to a UTF before using it. The other thing you need to know about this API is it only works with RFC 2822 messages. Now, don't worry about the terminology. This is just the standard for email messages nowadays. This is the simplest RFC 2822 message I could come up with. If you just look at show original in Gmail, you'll see something like an RFC 282 message. Don't worry about it. The point I'm trying to make is use the libraries to create this. If you need to create a message like this, JavaMail is a good library to use. Python has libraries as well. Probably best to not try to make these yourself. But sometimes if you have some files in inbox format, the actual emails themselves may be already in this format. Just a heads up. Let's see how to use this in code. We're going to use the same Google Data Python client library. The service class to use is called the migration service class. We're going to import the class. We're going to instantiate a new object. Let's grab one of these emails from disk. So I already have an RFC 2822 mail message there. I'm going to read it into a variable called mail message. Now here's the great part about this API. You don't just migrate it. You can do things to it. I'm going to add some properties. I'm going to say, this particular message is going in the inbox, and it's going to be starred. I'm going to give it a Gmail star. And I'm going to add a label. I'm going to add a label called migrated. Let's put it all together. We're going to call the ImportMail method of the service class. In this case, I'm migrating this mail message into Michael's inbox. I'm going to add those properties, and the mail message itself is in the mail message variable, and that's pretty much it. Now, if you have a lot of messages to migrate, you can use the same strategy that I illustrated before with the provisioning API to do high-throughput mail migration. A few more tips for this. Maximum size for migrated email is 25 megs. This includes attachments. And we don't allow migration of any executable files, even if they're compressed. So Superdeep is very happy. He's used the provisioning API and the email migration API to handle these kind of tricky customer cases. And before we leave Superdeep, let's add these APIs to our toolbox of administrative APIs. We'll come back to these in a minute. OK, so Superdeep's case was pretty happy, pretty regular. Let's talk about another person who's experienced challenges. I'm going to tell you the tale of the university administrator. I don't know if there's any university administrators here, but I know you work very hard. So meet my friend Oscar. He works as a system admin, a head system admin at a large state university in this state. He's got tens of thousands of users. He doesn't just have students. He has administrators. He has faculty, staff, and he even gives out alumni accounts to the alumni. So he's got a lot of user accounts. So remember what I talked about earlier with simplicity. Oscar requires simplicity in his IT infrastructure. He doesn't want multiple points of failure. He wants to administrate all user authentication via a single directory, like an LDAP server. And he has many web-based services. He wants Google Apps to appear as just one of many web-based services. Let me illustrate what I mean. So he has many services, web-based services available to his students. He might have a student contact directory, maybe a learning management system, and maybe a billing system. And he wants to comply with some kind of university identity management policy, which is that all of these services must be authenticated through a single source. All right, so he doesn't want his user authentication to get out of hand. He wants to use Google Apps, but he can't deal with two user authentication systems. He wants all that auth to be handled through a university login portal that interacts with the LDAP server that he set up. He needs a single sign-on solution for Google Apps. What does he do? Well, he can use SAML-based single sign-on, which is a feature of Google Apps. It allows you to incorporate Google Apps into your existing identity management policy. Let me show you how it works. So normally users authenticate themselves to Google Apps through the familiar login system. When you activate single sign-on, a SAML-based single sign-on, it delegates all authentication duties to the customer's SAML-aware portal page. Right? Single sign-on settings are set through the control panel. Essentially what you do, what Oscar's done, is he provides a redirect URL. This corresponds to his portal URI. Google Apps will automatically redirect the user's browser to the university portal when Gmail or any Google services are accessed. Now, SAML is a big subject. I could probably talk for 2 hours about SAML. I'll suffice it to say, if you're interested in this feature, we delegate all password and authentication authority to the customer, including password changes. We adhere to the SAML 2.0 standard, and we only support one type of flow, and that is the resource provider-initiated flow. There's also an identity provider flow. We don't officially support that. I get that question all the time. OK, so this is great. So he's set up Google Apps behind his portal. He's happy. It works. So now he's got a problem. And maybe the problem, if you've seen the headline of the biggest newspaper in the city today, the headline was, California State University, tuition may skyrocket. The budget is tight. The chancellor of the university is conducting a financial audit. He wants to know if they're spending too much money on IT support for things like alumni or extraneous IT support that they don't need to pay for. How many university email accounts are being used? Are students using POP and email clients? Do we need to support them? What about alumni? Do we need to waste resources supporting alumni? Are they even using their alumni accounts? Right? So what Oscar needs to do is compile a report, a financial audit on his department. Who's using the university email system, right? How many accounts have been created? How many students are using their accounts? How are they logging in? How do you do this? How do you do this automatically? All right, so he can use what we call the reporting API. This allows you to generate reports about user activity on a Google Apps domain, things like account creation date, account activity. Are people using the POP or the IMAP clients to access Google Apps? Or are they using their webmail? This is one API that I'm going to talk about today. It doesn't have very good auth support. Currently, we have to use the client login interface. We're looking to improve this soon. We also don't use the Google Data Protocol. We use a different XML format to post information. Again, don't have to worry about this too much unless you're writing shell scripts. Better yet, to use one of the available client libraries to do this. This is what the same call would be using the Python reporting API client library. It's very simple. We also have Java, .NET, and PHP clients. Let me show you what account report kind of looks like. This is just an account report for a single user. Normally, you would get one for everyone on your domain. It's basically an easily parsable text file with comma-separated fields. Let's look at what Oscar's trying to find out. He can write the script once. He can parse out the data he needs. He can send the Chancellor's office a weekly automated summary summarizing the results. So here we have the account name, someone named Michael, who hasn't been using his email very much. A last login date. We can also get last POP account if they're using webmail, when this account was created. So now Oscar can look at this information and he can parse out the necessary information. He can even create an automated script and send the Chancellor a monthly financial audit report, right? Now this is useful for a university setting. Imagine how useful this is for companies, right? Huge companies who need to lower their costs. They want to get a handle on what's going on with their user accounts. Which ones are being used? Should we suspend accounts that aren't being used? Should we take away some accounts because they're extra money in the budget? Let me tell you a few extra things about the reporting API. The data is not real time. It might be up to 24 hours old. What we do is we collate the information on everybody's domain once a day. And depending on when you call the API, that data might be 24 hours old. It is meant for reports. These reports can get big, too. If you have thousands of users and you're getting all this information, they can get pretty large. So we allow you to also send requests to compress the reports using gzip. OK, so this is great. This has been really helpful. And this is a very helpful API for a lot of people doing billing or other kind of account requests. Now, Oscar has another problem from the Chancellor, not as crucial. The Chancellor has a university emergency alert system. This is also an actual use case. The Chancellor he thinks that OK, let me explain the system. The system is, if there's a fire on campus, this alert system will send an SMS message to all the students, and it will also send an email to their inbox describing the problem. The Chancellor thinks that these emails are not conspicuous enough, and he wants the emails to be labeled important somehow. So Oscar is challenged with the task of finding a way to make these particular emails look a little more interesting to the students. What does he do? How does he do such a thing? Well, we offer two APIs that can help with these things. I'm going to lump them together, but they're two separate APIs. The admin settings API and the email settings API. So these allow for bulk updates of user email settings, also domain settings. These are really useful for building things like deployment tools and automating processes on your domain. The admin settings API lets you do things like set the domain properties. You can change single sign-on settings. You can change the domain logo, and a lot more. What we're really looking for here is the email settings API. This allows you to create Gmail filters, labels. You can set delegation settings. You can change user signatures. You can set delegation settings, and more. Just about anything you can do in the Gmail settings, well, to a certain extent, can be done programmatically for any user on the domain. Let's see what Oscar needs to do to use the email settings client to fulfill the Chancellor's wish. So in the Google Data Python client library, the client is called the email settings client. We're going to import that client, just like before, instantiate the object. We're going to call the create filter class. Let me highlight the interesting parameters here. Anything from the address Chancellor at the domain with the word security alert will be labeled important. And you can do other things with this. You can set different properties. We're going to just use the simple example of setting a label. This is pretty simple, right? Just a simple call. How do we apply this filter to everyone on the domain? Let's go back to our toolkit, and we'll grab the provisioning API again. Remember, before I said the provisioning API can be used to create user accounts. It can also be used to retrieve user account information. We can use this API to grab the names of everybody on the domain, iterate through the list, and set the email settings filter for everyone on the domain. Let's take a look. We're going to call the retrieve all users method of the provisioning API. We're going to put the information into an object called the user feed. User feed contains information about each user. We're going to iterate through the entries in the user feed, and we're going to pull out the username, and we're going to run that same create filter call on everyone on the domain. Now, like I said before, it's important to don't forget to add some exception handling, as we did before. We're going to grab that apps for your domain exception handle, and we're going to handle the error in whatever way we need. So that's pretty simple. Oscar is very happy. He runs a tight ship, and he has very little budget. But these APIs allow him to come up with some of the, to address some of the challenges that the Chancellor's office has provided for him. We've seen how Oscar's used single sign-on, the reporting API, and these admin and email settings APIs. So let's throw those APIs into our toolkit before we move on. OK, final story, a little bit sadder than the others. We're going to talk about the financial services CIO. I wonder if there's any CIOs in this room, maybe. Meet Carol. So Carol works in San Francisco as a CIO of a financial services company. I call this a small business, but actually they're pretty big. They're growing fast. They handle corporate investments. She switched to Google Apps because she loved the fact that she didn't have to worry about hardware, software licensing. It simplified her job. And she wants her IT staff to build the business, not worry about legacy email servers and licensing. Great, sounds wonderful, right? Security is better. But Carol has a problem. Carol thinks one of her user accounts has been compromised. One of her employees lost a laptop in an airport in New York. Now recall that her office is in San Francisco. And he did something that you probably see a lot with your employees, in that he kept a password to his Gmail account in plain text on his desktop. People do all kinds of things with their passwords. They might put them on stickies and put them on their monitors. I've seen people write their passwords on the bottom of their laptops. So Carol has a problem. She needs to find out if this account has been accessed. Of course, she got the user to change his password, but what happened in that 4-hour period when he lost his laptop? So Carol can use something we call the Audit API. And this is a very powerful API. It does basically 3 things. It allows an admin to download an encrypted file of a domain user's email. Also, you can grab an account activity report of a user, also encrypted. Or you can create an email monitor. This allows you to silently forward email to another account. Because this is an audit API meant for legal compliance, all this happens without the user knowing what's going on. This is meant for handling legal issues, compliance issues, things like that. As such, it's not useful as a backup utility. We only allow 100 requests for reports a day per admin. Sounds like a lot, but on a big domain. Since this handles very sensitive user data, before you can use this, you have to do more than just authorize to the API with an admin account. You must generate an OpenPGP public-private key pair, because everything that comes back from this API is going to be encrypted, and the only one person who can open it is the person with that private key. So before you do anything, you must first take your public key, base64 encode it, and then upload it to the Audit API. You can't make any calls for a mailbox dump or an account activity report without this step. Now, this is a little tricky to do. We have instructions on our website about how to create these public-private key pairs, but actually uploading it, it's best to probably use the client libraries. Oh, and by the way, before I get into this, is Jay Lee here today in the audience? He's one of our open source client contributors. He wrote some of this part of the library. OK, just checking. Wanted to give him a shout out. So in the Google Data Python client library, the methods to call reside in the Audit Service class. We're going to instantiate that class. Let's read a non-base64 encoded, since this library does it for you, public key from the disk. Put in the PGP key variable. Now we're going to call a method called updatePGPKey, and that's it. This will upload the public key to Google, so we can encrypt everything we send back to you with this key. It only needs to be uploaded once. Once uploaded, you can start making requests for a mailbox dump or user activity report. What Carol needs to do is make one of these user activity reports. This report will allow her to see when an account was accessed, if logins were successful or were there failures, and then what time were they accessed. So let's take a look. Let's go back to the library. I'll show you the code. The first thing Carol does is she uses that Audit Service class. She calls the create account information request method on the user, Michael, who lost his laptop. I've never actually lost my laptop. what comes back is a status. This is an asynchronous call. Let me explain what's happening. What's going to come back is a request ID for this particular request, a status message about if this request has been completed or not, and some information about the user, of course, and of course an admin account too. So this way you can audit the admins who are making these requests. The request ID is very important because we're going to use that again. Now we have to see if this account activity report has been completed. The reason that it's asynchronous is because Google will go out, collate all this information, make sure it's right, encrypt it, and then provide it back to you. We want to make sure it's complete and correct. Once you've created an account request, you have to go back and check to see if it's complete. Now, an activity report is just a list of login times and IP addresses. Not very large. It usually doesn't take that long to complete. A mailbox dump of gigabytes of information may take a long time. It may take up to 3 days, depending on how much information is out there. We want an account information request. Let's run the get account information request status method using the user Michael, and we have to include that request ID. If the status is still pending, we'll get something like we saw before, a pending status response. But let's say we've checked it again. We're going to get back something like this. So let's see what the difference is. The status is now completed. We have 2 new parameters, right? We have a number of files, and we'll have a URL. And the number of files corresponds to how many, well, the URL corresponds to the activity report or the mailbox dump. And if these mailbox dumps are very large, gigabytes of email, we'll split them up into different files. An activity report is usually pretty small, so there's only 1 file. That URL is what Carol's going to use to download the account activity report, which is encrypted. Let's check it out. So Carol's going to download her activity report from that URL. It's encrypted, of course. She has the private key. She's the only one who can encrypt this sensitive user data. So she's going to use her private key to decrypt the file. Looks something like this, right? It looks like the output of the reporting API. So the decrypted accounts request file is an easily parsable text file. It includes information about the user, some services available to them, as well as additional information about account login attempts, date stamps, and IP addresses. Let's zoom in and take a closer look to see what Carol sees. So let's see. Looks like there's some login success and failure there at the bottom for Michael, who lost his laptop. Where's the suspicious IP address? Looks like maybe there. Where is that IP address? She's familiar with the IPs for the logouts and the login successes. Those looks like the IPs of the network she uses in San Francisco. So Carol can use a geo-IP lookup, and she can see that the IP for the suspicious login failure was in New York, where the user lost his laptop in the airports, right? So you can see why this is a very useful API for doing these kind of audits. Sometimes you might want to know, how many unsuccessful attempts are being made on some of your accounts. Sometimes this is useful for proving that you have the ability to audit your account's activity. It's also important for enforcing employee policy, especially at a place like a financial services company where this is regulated by regulations like Starbucks that we talked about earlier. Okay, so sounds pretty sad. Carol needs a stronger way to protect her user accounts. What is she going to do? Well, she's going to use one of my favorite features of Google Apps, and that's two-factor authentication, right? So normally, you log into Google Apps with something familiar. It's something you know. It's your password and your username. Two-factor authentication adds another factor, something you have, and most of you have cell phones. What two-factor authentication will do is provide you with a one-time password every time you log into Google Apps on your phone via SMS or by an application you can download. It works something like this. So normally you put in your password and your username, like that. Once you put it in and it's accepted, you'll be asked to enter a verification code. And of course, this verification code, as I just mentioned, comes up from your phone. That's the second factor, and you're able to authenticate. This is really useful. This is an industrial strength enterprise security feature that we bring to everyone on Google Apps. So for applications that lack input, we can use, like POP and IMAP clients. We also offer something we call application-specific passwords, and we also offer the ability to create backup passwords in case you lose your cell phone and you need a way to get in. So all of these things have been thought out really well. It's very useful. Okay, so what have we done? We've talked about the Audit API, and we've got two-factor authentication. Carol's very happy. She loves these enterprise security features. She's got a small company, also a tight budget, and these have been very helpful for her business. All right, let's add the Audit API to our toolbox. Okay, so I've shared with you 3 stories about how the admin APIs are used in various reporting and compliance and security issues. Let's go all the way back to the beginning of the talk. And let's see what all this means, right? So earlier I said that we offer great security, availability, and uptime, and we offer great enterprise-level security features. But there's one more thing I want to add, and that is this toolbox of administrative APIs for compliance and reporting. So for you managers out there, we're always improving the extensibility of Google Apps and the functionality with new APIs. And there's a lot of exciting things that are going to come out in the next year or two. And I hope you stay tuned. It's going to be really great. We depend on your feedback to come up with these features. And since regulations change, compliance change, standards change, we are able to change with the times. And for developers, you have a lot of potential customers out there, right? The amount of Google Apps users is growing tremendously. And there's a lot of custom needs. I just showed you 3 different stories of people with really disparate needs. But they're crucial. And sometimes people just don't have the IT experience to do what they need to do. And that's where the developers come in like you. We need you to build these tools and build new products to help these people. OK, so we're kind of running short on time. I'm going to leave a little time left over for Q&A. Before we do, let me just pitch a few things to you. So some of the documentation about these APIs I talked about and the features, they're available at code.google.com/googleapps/docs, or just Google for them. You can post feedback at this feedback link that I showed you earlier. Please do, if you have time. We want you to stay connected. The best place to look for new features is to go to the Google Apps Developer blog, which is at Google Apps Developer Blogspot. And finally, we'd love you to join the, if you're a developer, join the Admin API Developer Group. It's there's a lot of people in this group, and we respond very quickly to questions for the APIs. And so go ahead and join, and we'd love to hear your feedback from there too. OK, so that's all I have prepared. I'm ready for Q&A. I hope you enjoyed the talk. All right.
When the question was asked about a year ago, Google was not considered HIPAA compliant in terms of protected health information. Is there anyone at Google to ask regarding direction toward HIPAA compliance?
Right. So I'm probably a bad person to ask about that. You should definitely talk to one of our, and I'm not sure if they're here right now, one of our PR people, or send a message to one of our enterprise representatives on the Google Apps enterprise page. So the problem that we have sometimes is I don't know exactly which regulations that we're complying with. They change all the time. So, but there are people at Google that know this information. Yeah.
Great. Thanks. I just wanted some clarification upon the limits.
Yeah.
Are those for mailbox requests, audit requests, or like both?
Both.
OK. So it's 100 flat per day?
Yes.
OK.
Yeah, it's not meant to be used as, like I said before, not meant to be used as a backup system. And it's doing a lot behind the scenes. So yeah, 2 limits for that purpose. Sure.
Hi, two questions. One on API in general. Is Google thinking about some sort of auditing the usage of the APIs? If you imagine a fairly big Google Apps account of 10,000 users, probably there's going to be more than one admin, and there's going to be several admins, and there's going to be probably third parties that's going to be accessing my domain and accessing my data with APIs. And maybe I would like to know, who's using which API when for what data.
Excellent question. The answer is we're looking into it. We don't have an API that does this yet, but it's something we're working on.
And regarding the Audit API specifically, I think the Audit API is very powerful. Nevertheless, in the wrong hand, could be very harmful also. So is there any way to, or is Google thinking on some sort of workflow on authorizing the usage of the Audit API? And or is there any way that I can disable the Audit API for some domain?
Yeah, so the Audit API, that's a great question. Actually, the Audit API can only be enabled once you enable the provisioning API. So you can actually disable it in the control panel. As for what you said, an ability to authorize it, you said it's very powerful. That's what that public-private key pair is for. It's almost like 2-factor for an API.
Okay.
So we work with some people who use PCI DSS or under PCI DSS regulations for taking credit cards. And that seems to require a continuous audit of logins, whereas this appeared to be just a single query for an individual user. Is there any thought to a continuous feed of this, somewhat like the syslog I get from my own servers?
How continuous? Well, so let me answer your question twice. No, we don't have an API that does that. And the Audit API, you're right, it's not something that works continuously. It doesn't notify anybody about an account access. But in your experience with PCI compliance, how continuous are you talking about?
Well, what we get currently is, this guy logged in, then this guy logged in, and this guy logged in. So it's a pretty continuous flow. I'm not sure whether the regulation would, it would probably be satisfied if you could do a poll once a minute and get all the logins that happen, but it's mostly that it's looking at everybody's account pretty rapidly.
Well, I'd like to talk to you about the requirements of that. The short answer to your question is no, the Audit API doesn't actually provide that functionality.
Question about single sign-on. There's a link you can link user to do the single sign-on and also sign out. So for logout, usually, we do try to delete cookies and things like that. Do you have a reference how to do that?
Right. So yes, let me say something about that. Google Apps doesn't support single sign-out functionality for various reasons. One is because once you sign out of Google Apps, we don't know if you've signed out of everything completely. We leave that all up to you. For a reference, there's two softwares you could look at. I don't know if you use Shibboleth or Simple SAML PHP.
Shibboleth.
Yeah, you use Shibboleth. Okay, so this is a limitation of Shibboleth as well. The only real way to do single sign-out is to actually create a function that closes the browser window when you've signed out. You probably have seen that already. The answer is Google Apps doesn't do anything for that. I think you should look at what Simple SAML PHP does, which is attempt to sign everything out, sign everybody out of every service once the sign-out link is clicked.
Okay. Second one, simple. The reporting Python library that you just showed does not seem to have IMAP.
Does not seem to have what?
IMAP session. IMAP login, last IMAP.
Oh, I'm sorry. Yeah. So
you have last pop, but not IMAP.
Right. We could, as far as I know, I might be mistaken by this, but I think we combine the IMAP and POP, accesses in that one variable. So it's basically webmail versus non-webmail. Is what that
so
reports.
Last pop maybe is last IMAP. That, right?
Yes. Oh, I see. Yeah. There's no differentiating on our end about is it POP versus IMAP. It's just an email client versus, or I'm sorry, a desktop email client versus a webmail client. Do you have a requirement to separate those two?
Well, it's just the title is confusing. I can go back to do some testing. I thought it's just POP.
I agree that the label is slightly misleading.
Yeah. All the APIs that you mean provision API and all the email setting and all that, do they support OAuth 2 or OAuth 1?
Everything that I talked about supports OAuth 1 except for uses OAuth 1 except for the reporting API. OAuth 2 Flow is not supported by any of these APIs yet. We're working on that right now. And I hope to get that soon, actually.
Okay, OAuth 2 is not supported yet.
Right, exactly.
But OAuth 1 is okay.
Yes, the OAuth 1 flow is supported with these.
Okay, thank you.
Oh, let me add, I said this earlier, but we just published an article about using OAuth 1 flow for web-based applications with the provisioning API. If you're interested in learning more, that's a great resource.
Hey, when you get the dump for an email's mailbox and you decrypt, does that decrypt everything into clear text?
Say that again? I didn't hear the last one.
Sorry, when you decrypt the user's mailbox, do you see everything in clear text?
Yes.
Everything?
Yes.
Okay.
I had a quick question kind of along the lines of the gentleman who's talking about PCI DSS.
Yeah.
Have you seen any implementations where the people are using the Google Apps engines to keep track of which users performed which actions in the system so that you have an audit trail for all the activities that took place, for example, on a particular, if you're in financial services, for example, for each of your customers, you need to have an audit trail for who made changes to the account.
And which type of, so are you talking about administrative functions? Like,
yeah, basically if you're a customer service rep, for example, or if you're in fraud management and you make a change to the account, you block it, or you block the person's card, you change their address, you change their date of birth, that kind of thing.
Yeah.
You need to be able to look in the system and see who made the change. Have you seen any implementations with Google App Engine that use that kind of functionality?
I'm not familiar with any. It's something that we get asked about from time to time, and it's something we're looking into on our end for different ways to audit things that are not user accounts but actually administrative actions. And that's something that we're looking into, but we currently don't have a particular API that does that yet.
Okay, thank you.
Hello, I'm just wondering why the chats in Gtalk are not auditable. You cannot get it, well, with the Audit API you get it, but only if the user has their setting, like to store chats history. And the administrator cannot force the users to keep the chat history?
I see. Yes, this is an interesting question. So it's kind of like two-part question. One, actually the Audit API will let you download a dump of chats that were on the record, but you're asking basically, can we force chats to always be, is that what you're asking? Yes. So these kind of additions to Google Apps, these kind of requests for things, we're also looking into different ways to do these things. Again, I don't have an API that will provide you with that information, but it's something that we've been asked about, and we're looking at the possibility of these things.
Thank you.
Mm-hmm. All right. So I guess there's no more questions. I don't want to run out of time here. I think you guys should go out and enjoy the rest of Google I/O, and let's call it a wrap. How about that? All right. What's that?